Under Carlos Nunez, and I'll talk about a project that I've been doing with Solomon Zacharias, who is a postdoc at Swansea University. And we have been looking at double non-abelian T-dualities. So just abbreviate them as one and a T. So a T-duality is this duality in string theory where strings propagating on a background spacetime with one direction compactified in a sphere with radius r has the same physics as when this direction is compactified on a sphere with radius 1. So you have this abelian isometry in your space. Now, I can start.
He's going.
Okay. Okay, so another abelian T-duality is a generalization of that when you don't have an abelian isometry, but you now have a non-abelian isometry. For example, a two-sphere or a three-sphere. And you can use that, what we've been looking at is when you now have the ADS5 times the 5 solution, that we had a very nice introduction yesterday. You can use this on abelian T-duality to on parts of this supergravity solution to come up with new supergravity solutions. And in the context of ADS-CFT, it's quite interesting to see what the new field theories are that you're going to get, or just what new supergravity solutions that you can come up with, because it's quite hard to come up with arbitrary supergravity solutions. So a while ago was worked out by Kostas Spetsos and Daniel Thompson that if you do this non-abelian T-duality on a tree-sphere in the ADS5, you will get, a tree-sphere in this 5-sphere, that you will end up with a space-time that still has this ADS5 isometry and is remaining as 2 isometry that you leave untouched. And then along the radial direction, you will now get these NS branes that you get over there with stacks of D4 branes. NS branes and D4 branes. And the excitations of this system are going to be these strings that go from one stack to the other. So at low energies, this will be described by a quiver super conformal field theory in 4 dimensions. And then a year ago, Solomon Zacharias, who is at Swansea University, with Carlos Nunez and Jeroen Lozano, they worked out what's going to happen when you now do the same thing on a tree-sphere in the ADS5 isometry. Using that, in global coordinates, ADS5 is this analytical continuation of the 5-sphere. And then they found that you break these ADS isometries, but you still have this time isometry, 2-sphere that you leave untouched and the 5-sphere that you leave untouched. And again, you will now find these NS branes, but now with the 0 branes in between them. And where this thing fits into the Gagotto-Maldacena classification, and it's this quiver gauge theory, this thing, because we have these 0 branes, so there is no CFT. Here. So this fits in the Lindblom and Maldacena classification. And in this case, you will get something that is described by the BMN matrix model. And what Solomon and me are now looking at is what is now going to happen if you would do the non-abelian T-duality of both at the same time. What are you going to get? Because you start out with this type 2b solution that has 32 supercharges. And when you do this non-abelian T-duality, just like when you do a normal T-duality, because it's on a tree-sphere, you have 3 generators. You go from type 2b to type 2a, and you will get a half BPS solution. So these two both have 16 supercharges. And now when we do it again, you will get, you'll go back to type 2b, and you will be left with 8 supercharges. And what's going to happen for the NS sector is pretty straightforward, because when I do another abelian T-duality in one of these sectors, the metric and the dilaton and the B2 field, they're not really going to be affected by what the other subspace looks like. So when I do it on both, I will basically get, in the NS sector, you will sort of get a superposition of the deformation over here, the one over here and the one over there. But for the Ramon sector, it's going to be less obvious, because you will get all these Ramon fields. You don't really know what's going to happen with them because they transform into bisplayers. So what happens, turns out that it doesn't matter in which order you do it, because if you do it first in the S5 and the ADS5, you get the same as when you do it the other way around. And in both cases, because we get the superposition of the NS sector, you will now have these two row directions corresponding to these two different non-abelian T-dualities, where you get this grid of NS grids with these sort of boxes, these ring boxes where there are now D1 and D3 grids. And the questions that we're looking at, we hope that this is going to be on the archive, we hope later this month, it would be nice. So we have this solution and what the ring configuration looks like. At the moment we're looking at so this is again going to be described by a matrix model. But because you destroyed so many isometries, there isn't really a classification of what this particular solution is going to look like. So it would be nice to try to find a more general classification of solutions with these remaining isometries, and to find more precisely what this matrix model is going to be with 8 remaining supercharges. So that is what we are working on. Yeah, we hope to get this classification and the matrix model out somewhere during this time. We were some complicated. So thank you very much. Any questions?
Yes. So the body quiver is in 4 dimensions. This new model, how many dimensions is it?
So you have these D1 and D3 brains in these brain boxes. So it's going to be again a matrix model at low energies. So it will be the 0 plus 1 dimensional quantum filter. Yes.
Do you have an ADS3 factor?
No. So when you do the non-abelian T-duality on this ADS page, you sort of destroy the ADS observation. So
The magic remains the same if you do it twice. You said?
Yes, because if you do it first on this one, then you only deform the S5 that you still had in the Linden-London classification. You deform it even, you break those isometries even further. So it's, in a way, you can see it as some sort of non-abelian T-dual deformation of the BMN matrix model. So there won't be any ADS factor in the resulting space.
So
you basically have the time isometry that you have when you did it over here, plus the 2 sphere that you leave untouched, and then the 2 sphere that you leave untouched over here.
Done with saying Jeroen.